Let's talk about the intermediate value theorem, which I will frequently abbreviate IVT. My name's Tuesday J. Johnson. I'm a lecturer at University of Texas El Paso and an assistant professor at Doña Ana Community College. This particular lecture is for Math 1411, Calculus at UTEP. Chapter 1, Limits and Their Properties, comes from Larson's 11th edition calculus text. This is section 1.3, one-sided, oh, I lied to you, it's 1.4. Continuity and one-sided limits. This is part 3 of a 3-part series of that section, specifically on the intermediate value theorem. So let's start with a definition, really. The intermediate value theorem states, if f is continuous on the closed interval from a to b, and the values at the endpoints are not equal, and k is any number between f of a and f of b, then there's at least one number c such that, in the interval from a to b such that f of c is equal to k. So wait, what does that mean? While driving from home to work, I start at 0 miles per hour when I get in my car, and I get up to 75 miles per hour on the highway, the posted speed limit. At some point in between there, I must have been going 55 miles per hour. I can't go from 0 to 75 without first passing through 55. Alright, let's take a look. We're going to verify that the intermediate value theorem applies to the indicated interval, and then find the value of c guaranteed by the theorem. Our first one's a polynomial. Let's take a look at what happens. F of x equals x squared minus 6x plus 8 on the interval from 0 to 3. And I want to know, is there an f of c that is equal to 0? So first we're going to verify that the intermediate value theorem applies. We have to make sure that f is a continuous function, but f is a polynomial, so we know it's continuous. We find f of a, f of the left endpoint, f of 0 gives me 8. F of b, f evaluated at the right endpoint, f of 3, gives me a value of -1. So the values at the endpoints are not equal. That's fantastic. We know that the value k that we're looking for is between -1 and 8, so all the conditions of the intermediate value theorem are met, and we can find this particular value c. So how do we find the value c? Well, literally, f evaluated at c needs to equal 0, so I'm going to evaluate f at c. That's c squared minus 6c plus 8 equals 0, my k value. I can factor c squared minus 6c plus 8 into c minus 4 times c minus 2, still equals 0. And then use the 0 factor property. If two things multiply together to give me 0, then one of them must have been 0. In this case, that means c equals 4 or c equals 2. However, we're looking in the interval between 0 and 3. Is 4 in that interval? No, it is not. Our only solution is c equals 2, as it's the only possible output in the given interval. So pay attention to your interval. Alright, how about f of x equals x squared plus x over x minus 1 on the interval from 5/2 to 4. We know that this rational function is continuous everywhere except at 1, right? Domain value, we don't have a domain value of x equals 1, but that's not in our interval. So in this particular interval, our function f is continuous. F of 5/2 is 35/6, which is a little less than 6, right? It's 5 and 5/6. F of 4, f evaluated at the right endpoint, is 20/3, which is a little more than 6, right? That's 6 and 2/3. And our k value, 6, is between 35/6 and 20/3. So all of the conditions for the intermediate value theorem are met. We can find our value c. To find the value c, we evaluate c squared plus c over c minus 1 equals 6. Just evaluate our function, try to set up this equality. In order to solve, I'm going to multiply both sides by my denominator, c minus 1. We already know we're not going to use a value of 1, so this isn't cheating. I'm not multiplying by a 0 because of our interval. It's all good. When I multiply both sides by c minus 1, on the left, I have a c squared plus c. On the right, I distribute 6c minus 6. It's a quadratic. In order to solve the quadratic, I'm going to get everything on the left side, get it equal to 0. So I'm going to subtract 6c. c minus 6c is minus 5c. I'm going to add 6 to both sides. I have 0 on the right, and I can factor the quadratic on the left. c minus 3 times c minus 2 equals 0, which tells me c equals 3 or c equals 2. Once you get your values, always check back with the given interval. 5 halves, that's 2.5, right? 2.5 to 4. 2 is not in the interval. 3 is the only possible answer, as it's the only one in the interval. All right, here's a little example, real life, bring it to you. At 8 a.m. on Saturday, a man begins running up the side of a mountain to his weekend campsite. I don't know why he's running, but let's just go with it. On Sunday morning at 8 a.m., he runs back down the mountain. Never a safe idea, people. Be careful. It takes him 20 minutes to run up, but only 10 minutes to run down. At some point on the way down, he realizes that he passed the same place at exactly the same time on Saturday. We're going to use the intermediate value theorem to prove he is correct. Now, first of all, if I was running down a mountain, I probably wouldn't have time to think about the intermediate value theorem, but let's go with this situation. So, he's leaving at 8 a.m. on both days. On Saturday, he runs up the mountain, and it takes him 20 minutes. On Sunday, he starts at 8 a.m., he's at his campsite, and he runs down the mountain, and it only takes him 10 minutes. Notice, somewhere between 8 and 8:10, there's a time he was exactly at the same distance from his base and his campsite. Interesting. That's all I have to say about that.